Hi, it's Gadget UK here again. Super excited today to receive this. As you can see, another year older, unfortunately. Anyway, let's not think about that, it's too depressing, but yeah, what a lovely surprise. So this has kindly come from all the guys and gals in my Discord straight away. Oh, that's caught my eye, look at those. It's like died and gone to heaven type food. Those look absolutely gorgeous. Oh, I'm going to have to try and ration myself on those. Eye candy. Oh, more chocolate. Oh, fantastic. I love these. These are my favourite ones as well because I like all the different things here. The cream egg, caramel as well, double decker, crunchy, dairy milk, whisper, fudge, squares. Oh, thank you ever so much. Just those, the cupcakes on their own, you know, amazing. But even that on its own is amazing. Wonderful, wonderful surprise. So we've got what looks like some project stuff here. This is super interesting. We've got a load of sockets here, dip sockets, a PLCC socket there, and then we've got some switches and stuff here. I wonder what these switches are going to be for. Resistor arrays, some SMD caps and things. Don't know what those are. RAM or GALs or something maybe. Yeah, so we've got I don't know what that is. Looks like it's got the ADV thing on it. Is it some sort of DAC? Could be a DAC actually. But then we got some more components here, a little inductor, B variant. Then I have an IC there, some resistor arrays, and Multifix AGA V0.3. Matthias Heinrichs again, free for non-commercial reproduction. It's got a Xilinx chip on there. Look, that's nice. I like this. AGA Multifix. I wonder what this does. Is it Scandoubler or something? So maybe we got some GALs or something go here, or I don't know. Mind you, you've got that, so maybe you wouldn't need GALs. Maybe this is for RAM. It could be like line buffer RAM. Maybe this is like a Scandoubler for an AGA system. It could be. And that's maybe what goes here. VGA. So you connect to, you can connect to VGA monitor. I mean, that's just amazing. I'm blown away that they would think of me and get together these things together like this. So yeah, that's going to be the title of this video. It's not just going to be a opening a box. I think we'll build this within this video and see how we get on with it. But I'm blown away. Thank you ever so much. Thank you ever so much for this. This has really made my day today, and it's a little bit after my birthday, but yeah, you'll know that those guys and gals know that I've been a bit depressed for the last 3 weeks and struggling a bit with my channel. I'm way behind with videos and various other things. So yeah, I'm very, very, very grateful to receive that. It's just wonderful. Thank you ever so much. And then a wonderful card. It's your birthday, dear Chris. Typical Discord fashion. It's a tad late. A really great happy day. Retro Crazy Screamo. That's Stefan, Andy T, Tom Meads, Call 286, Avalandia, Barnarabus. I can never say that name. Palmer. Pelluck, CRG, Retro Game Revival, Plan C, Biogames, Sparks, and all at Discord. I'm very, very, very happy. Thank you ever so much. Brilliant. I'll stick that on the mantelpiece. This is a week or two later. I'm not sure that's part of this actually. I think that's for something else. This is a few weeks later. Sparks kindly sent me some more parts. I'm not sure there's any logic on here. I think this is all RAM actually. Could be incorrect. So you can take out those RAM chips there, and then if you take the bits out of here, I think those are going to be the small chips. Those are going to be the larger chips. We've got the socket for that, and the chip for that, I think. Now Barry kindly sent me a message and said that I think 3 of these boards had needed that CPLD reflowing. And also, he pointed out that there's a problem with the brightness. He showed me a screenshot, and I was like, oh, that looks fine, but it looks a bit overbright. And he says, yeah, I think he said that Matt Harlem had worked out you need to short some connections on a diode or something here, so I'm not sure if there's a problem with that. I think Barry said that it might be the diode's incorrect type or something, or the incorrect size. So I don't know. We'll see how we get on. We'll see whether it looks overbright on mine. But also, yeah, reflowing here. As I say, 3 boards. These came from JL PCB, incidentally. So for whatever reason, the soldering on that is not so clever. But it's really good that all this, bird seed here, chicken feed or whatever it is already fitted. There's just some small stuff here, a few small components on that side maybe the odd thing on the top side. Obviously got a, there's the diode, D1, so it looks like a transistor to me, it's 3 pin, that's a bit weird. So yeah, we'll start with these sockets. I'll do the large ones first, I think. So if we just try and separate these. Pin 1's to the right on these here, and these ones, pin 1 to the left. That's a bit weird, isn't it? But I guess it may make sense in terms of the board design there. So yeah, we'll just solder these in place. So I'll probably just anchor them all that way first, and then you know, speed run through all the remaining solder points. Just doing that, just doing a point at a time, you can adjust them, because you know what, there's nothing worse than having like a socket like that, one like that, like a zigzag. They just look like a moron assembled them. Now technically I am a moron, but you know what I mean. So those sockets are just anchored with a couple of points each. I'm going to do this one and I'll do the smaller one. So here, I was like, where's pin 1 here? It's a bit cryptic, there's a dot up there, look. Yeah. But I was like, well, which way does the little slanted part here go? And if you look at the inner white print there, this is like a square, square edge, there's the little slice there. So it's going to go that way, I think. May as well just anchor these in place, and then I can solder everything at once. So yeah, this is going to go this way around. So you've got the cuts out there, and there's a little mark there where it has the number of pins of this, you know, the type of connector. So yeah, again, I'll just try and make sure that's straight. It needs to go down a little bit on this side, I think, just a wee bit there. Yeah, that's pretty straight. Better on that side. Yeah, that's looking alright. Anyway, I'll report back in a minute when I've got the other switch on. So I've got 2 more connectors here. One I think is audio. Now there's a thing up here that says left, right. So I think this is a bit like some of the other Scandoublers, like the one you may or may not have seen on my channel yet, which had an audio amp, and you could get audio out the back. I suspect that that's what this is though. I suspect there's a little amp on an op amp, and you get audio out of this as well as video, which is a useful thing, I guess. But I mean, you've got the connections on the back of the Amiga there anyway, so you could argue it's not a necessity, but it provides a bit of amplification as well. So yeah, it's just a nice additional feature, isn't it? Again, I'm just trying to get that straight because it's like, it's a bit crooked. You can see it's pointing down this way here, ever so marginally. So let's just heat that, and there we go, straighten it a little bit. Yeah, so that's our audio and our 2 switches. So the next thing is particularly interesting. Yeah, comment down below if I'm wrong, but that looks like USB. Looks like we've got 2 USB ports on here. So what this is all about, I honestly do not know. I wasn't aware this had a USB. So yeah. Anyway, that's nice, isn't it? Double height USB connector. So again, we'll just solder a couple of the points here until I'm comfortable it's in the right position. I'll start with one of those anchor points. You could argue the anchor points are the hardest thing to solder, so maybe don't do 2 of them at the same time. But you know what, I mean, that's pretty darn straight, isn't it? I can just commit to soldering the other points there now. So next we've got 2 4K7 resistor arrays here. Yeah, the common end is up there, isn't it? Let's just test that. If in doubt, always measure things with your meter. Sometimes you get mistakes on the silk screen, or I don't know, something like that. So those are simply joined together. Yeah, they are. And where's VCC on here? It's going to be up here. So it's not pull up, it's pull down. Is it? Oh, it's not. Well, that's interesting. Oh, hang on a minute, it's not 7.4 series, is it? It's going to be a tab on here, there we go. Yeah.
That is the ground.
So that's the common pin, the top one there. So on here, we just need to find the dot. Yeah, and the dot is to the left here. So it's going to go with its dot towards up here. There we go, that's not too bad. So this next component on first inspection can be a bit confusing, and I think this is perhaps where Liv2's done the mod. It says there D1 on the PCB and it's a 3-pin device. I'm like, well, it looks like a transistor. It's an LM385. It's a voltage reference, an adjustable voltage reference. So a bit like you get around the video DAC section on 1200 or other systems like that, 4000. It's probably provide, you know, it'll have a Zener in it. That's why it says D. There'll be a Zener in there. It's probably like 1.2 volts or something like that, or 2.4 volts. So yeah, I'd be interested to see how this looks as default, whether we have to do the mod that Liv did. So that's our voltage reference. I'm going to have it stood off the board a bit. You could technically push it all the way through and have really short legs, but anything that gives you component height off a board is better because you can measure, but also it just helps with any heat dissipation, although I wouldn't expect something like that to get particularly hot, really. Just grabbing those so they don't ping into my eye. There we go, that's that done. It's not quite as straight as it could be, but that'll do. What else have we got? So we've got some jumpers and things to fit here, and the VGA connector, and what looks like a little IC here, and obviously some SMD stuff on the underside, little caps and resistors perhaps. So we'll deal with that next, which I think is L1, which I've just took out of here. Yeah, that should fit on there. So yeah, I'm guessing that's what that is. Just a little inductor there. There we go. It's just lob it on there. So yeah, it's going to be a bit beefy to solder this. This is where you need a bit more heat and a bigger tip on your iron probably. I'm happy that's pretty central there. So we should be able to just solder this side now, and that should be it. Of course, we'll know if he's on because we'll have a join between these two sides here. Trying not to get sticky outy bit on it. Measure on connectivity, just to see if we've got a connection across there. Yeah, we do. Put on ohms. 1 ohm roughly. So other than the jumpers and obviously all the chip solder points on the underside, we are getting near the end. I've just got some resistors and stuff here, so let's get these out. Let's try and get through these. Oh, they're on the outside. Yeah, we'll get through these next perhaps. Now these aren't labelled up, so I don't know what they are, which is handy. So somewhere on here we've got some resistor array positions. Oh, here they are. Yeah, and the solder coated look, I hate it when there's solder coat on there. I mean, technically when you've got solder blobs like that, you could just put the resistor array on it approximately and heat with hot air, but I don't want to expose all this area here to hot air. There's one up there, look. Oh, we should spot that before I put that on. Anyway, I can manage that. It's not a big deal. So we'll start with that hard one, I think. And in fact, what I'm going to do is just get a little bit of flux on there. I'm going to use some braid, and I'm just going to mop up the solder that's already on there. It'll just make it far easier for me. But you could just use hot air, as I say, and that would perhaps maybe the easiest thing, to be honest. There we go, that's pads for one, tied it up. This one's a bit hard because I've got that little cap or whatever it is there. Gonna have to inspect that cap to make sure I've not removed all its solder. Yeah, there we go. So I can't really show you that. They're so small and fiddly to solder. So what have we got left, other than the solder points? These resistors and caps here, I think. Oh, and that little IC. Now these, I was just looking at the board. We've got FB, ferrite beads here, and then 1, 2, 3 caps, I think. So that would correspond. We've got some caps there, look. I'm assuming that's what those are, and I'm assuming these are ferrite beads. They look grey. So yeah, I can take one of these out, measure it, and assuming it is, these are going to be the ferrite beads to go here. These size of components are always the bit that make board builds like this quite hard, so there is definitely an advantage in having JL PCB. Put all these things on for you. So yeah, let me just try and measure that. Now I'm going to have to be very careful here, or this is going to ping off, never to be seen again. So I'm just going to gently touch it. Yeah, there we go. So we know that that is, hang on, a ferrite bead. Ferrite beads on there, just cleaning up the flux. I used a bit of hot air there just to straighten them up. Really fiddly to do those tiny little things. Those were harder than perhaps than the resistor arrays. Hang on a minute. Have I just pulled the thing off that? This is the problem, look, I've only got one cap now. Yeah, the tape's just come off, got stuck onto something else, and the caps have flown out. Got one there. That's two. Oh, where's the other one gone? I'll report back in a minute. Right, that's all three caps on as well. Yeah, that other cap, it was stuck to the piece of sellotape that came off, so yeah, anyway, at least I've found it and they're all on. So the only other thing now is jumpers, small IC here. Let's get that on next. Now this IC was in a bag cut marked IC14B variant, so I'm guessing there are two different types of IC you can fit there. This is the B variant. Yeah, so pin 1 is in the bottom left. Just trying to get that into position. Again, I should be using a plastic tool because this metal tool sticks to the blooming thing. Oh. Yeah, so I'll get it approximately the right position like that. Just come in with the iron. Add the smallest little bit of solder onto one pad. Hang on. You can see you can move the chip with the solder at this point. And that's how I tend to align that. You can see that's not bad. I'll just inspect that off camera. Yeah, that's pretty good. I've just turned it upside down. Yeah, you can see it's not that hard to solder chips like this, really. Magnification helps, and use some decent flux for sure. And just get a little bit of solder on the tip. I'm going to start from the side where I haven't anchored it. Anchored it here, so I'm watching out for this socket as well. Could argue get these things on at the start and just do a bit of bobbing in soon, dragging along. You can see that side is pretty good. And start over this side here. Just have a little drag along there. Yep, there we go. Again, we'll just clean around there with cotton bud. And on the last few solder points here, I've done all the other sockets on this and the connectors and things. And I can show you, sped up the process somewhat. I can literally zoom along these now. Of course, you could just get a chisel tip and drag solder along there, but yeah, anyway, it's not taking too long. About, I don't know, 25 minutes maybe to do all of the remaining solder points on the underside. Yeah, it's not too bad. Blobby solder points. I always get quite large solder points, you'll know that. So yeah, I've got just some jumpers now then, and obviously the VGA connector, that's it. Well, and then get the chips in, so we're pretty much there. Yeah, there's a solder blob here, can you see this? I soldered this. It says B to left A. Well, we put the B variant, so I'm guessing that's what that is. Blanking select there, neg or pos. So that's the jumper. We've got some jumpers up here. Well, that says 5 volts and analog ground, so I'm not sure you'd want to join 5 volts to analog ground, but I'm not really sure what there's a form. Some jumpers there. Those ones might enable the pass-through of the audio. I think they do actually, looking at that. And we've got a jumper down here that says dis N, enable or disable. This is where you connect up to the GBA P2 Plus, actually. That's the JTAG header, so I was wrong about that earlier. So the same problem I had with the GBA P2 Plus, which is my video cables do not like these sockets. I don't know why. There's some marginal difference. It could be that I've got cheap video cables and a cheap monitor, but nevertheless I'm going to go with one of those cheap ones, ironically, from eBay. Now the difference is it sits back like that, so it could be a problem if you've got a you know, a panel on here or something, but you could always just cut holes so that the cable can actually go into there or something like that. So yeah. But anyway, I know this will make a good connection, so I'm going to go with this. And because it's not exactly the same, I just need to bend the outward rows out a little bit. Yeah, not too much. I've probably done that too much there. Otherwise, it won't go on. Let's try that. There we go, what's going on. So yeah, it will be recessed a little bit, as you can see. It's not dissimilar to the USB though, so I think that'll be alright actually. Skirted over everything here really, because you've seen it all before. If you want to watch an example, just check out the A3640 video, top right. Or the TF330 maybe. Or the GBAP2++. So we've got the jumpers on all the positions here, even though some of these may not be needed. I think that's just like the points to connect signals rather than actually jumper points. So that's something to be aware of. Same up here, analog ground, you wouldn't want to connect that to 5 volts, I'm sure. But here, I think this actually is where you pass the audio through here. It looks that way. The connections, they come from here to one side of the jumpers, and then the other side the traces go to this 3.5mm connector here. So I'm not sure why these switches are 3 position. That's interesting. Maybe they're not supposed to be 3 position, I don't know, it might have been all that was available at the time. So we'll find out. Yeah, that says SCA, SCC I think, and ground, so that's, I don't know what that is. I haven't got the chips on there yet, obviously. The next thing I'm going to do is just clean up with cotton buds and IPA, but we'll get this in the ultrasonic afterwards. I just want to get rid of the majority of this because the ultrasonic will have a hard time probably removing every single little bit of that. The more of that I can remove when we stick it in the ultrasonic, it will then come out looking like a manufactured one. And it's interesting, it says here free for non-commercial reproduction. So yeah, don't get ideas about making hundreds of these up and selling them at huge profits. There are a few of these for sale on eBay. People like Sparks UK and various other people have been building a few of these, just a small batch, and just adding on their time and cost for parts, more or less. Whilst it's only took me about, I don't know, 2 or 3 hours in total to completely build this, you've got to remember that there's an amount of wastage. So for example, Sparks UK, who's built a few of these, ordered a load of these chips. They don't all work. He's ordered, you know, a number of other things. Some of them don't work. You know, I mean, I had problems with these video connectors. He seems to have been alright with the ones he's used. So most removed with cotton buds. But I'm going to brush it. I've shown you this before. I use a piece of sellotape, because when you've used cotton buds that aren't lint free, all these fibres, they stick, look, and they just get stuck in the blooming brush, and you spend so long trying to clean your brush afterwards. So yeah, a few pieces of this are going to be required. Yeah, you can start to see the difference there already. That is so much better. So this time I'm going to tilt it down that way. Let's have a scrub around here. There we go, that's not too bad. It will go through the ultrasonic there. So I think the next thing to do is program this up actually. I need to go and look at the pin out for the JTAG here, because, well, I mean, it's got a standard connector. I may well just be able to plug the cable I've got in, but I've also got the separate pins, and I don't know which one's which here. So the version of Impact I'm using crashes on Windows 10 actually, but what you can do is just close the dialog, double click on boundary scan, right click and choose initialize chain. Select your JED, and then hit program. And we'll do verify for good measure. So all programmed up. I'm pleased with the progress so far. I've got jumper there on the N position. There's a dis or N, so it's on the N. And this here, blank select, we've got positive or negative. I think it's on positive for the moment, which may be correct, I don't know. So switches both one way. I'm not really sure what these do. I need to go research that. But the next thing to do is get the chips on. So I've got the ESD wrist strap on. So I'm going to try and get this the right way. So the slice is there, which corresponds with this side here of the socket. Let's carefully push that in. That's that. There we go. Yeah, it wasn't quite correct. Pin 1 on these is to the right hand side, isn't it? Just give you a quick look at that. You can see hopefully the part number on it. NEC, and these are line RAM, aren't they? So they are quite hard to find. It's a miracle that Sparks, I think with the help of Live2 and Screamo, Stefan, managed to find what looks like a reliable supplier of these, but they're in short numbers. They are quite hard to get hold of. So let's just put that there. There we go, that's the first one. Now the legs on these smaller chips are solder coated, so yeah, hopefully they're going to be alright. Yeah, I think the speed of these was a question when we were talking about this in Discord a few weeks back actually, and I was a bit concerned thinking this might work with PAL but not when you switch to 60Hz, NTSC. Yeah, pin 1's at this side on these now. Making sure those are all in, yep, and pin 1, pin 1, pin 1, pin 1. Right, so let's just make sure the 4000 is still working. Yep, there we go, booted up. Anyway, let's switch it off. So, the strap on. The video slot, I believe, is the bottom one. Now, if we just sort of pull this into position. The disconcerting thing here is this little thing on the end here, because there's nothing that corresponds with that there. This is all one piece in terms of the slot there. So I'll tell you what, let's just disconnect the SID card. Might be a little bit stiff this, it probably still needs a little bit filing off it. There we go, let's take the SID card out a sec, just so you can see more clearly. Yep, that side is not going in, look. Might have to shave a bit of the edge off that, I don't know. Let's just try and, there we go. Yeah, it just needed a bit more persuasion there. So yeah, hopefully nothing's trapped under there. This is here, this can go back up there. On properly, there we go. So yeah, it's getting very tight with all these blooming wires and things, isn't it? Anyway, let's just power it on without anything. Well, I'll tell you what, we'll plug it in anyway. Let's plug the VGA in. Well, nothing's instantly exploded or anything. However, it's not booting, but I'll be honest, that's a normal thing with the Proto 4060 here now. It is. I saw the coloured lines. Yeah, flashing. Yeah, that's RGB. Let's switch to VGA. And that's not working now. It could be the switches. Let's try switching. Oh, hang on a minute. I'll try and hold this while I do this. Try switching one of the switches. And nothing. So that is a wee bit concerning. Switch it off. I'm going to change over that negative to positive thing. I'm not sure which side it's on. I'll tell you in a minute. Just see if that makes any difference at all. I guess what we should do actually is just switch the power off. I'm just going to take the compact flash card out. Let it just boot to the sticky disk in screen. It might be a little bit easier to see what's going on rather than having to wait for it to boot. There we go. See, it said 480i and then just went straight off. I'm not really sure what is going on there. I've changed that jumper over to DIS. It says SOG, and I was like, I didn't spot that the first time. Sync on green. So that's going to be one issue. We'll try and set that back there. You know, there's these three things here, but I'm not sure what that's used for. It says SCA, SC, SOC, I think, ground or something. So, yeah, I'm not really sure. What I do know is, unless a reflow around that is needed, maybe that caused it. Let's give it a try again. So I've just reflowed around that, and whilst I was doing that, spot anything obvious there? Anything suspicious around there? Anything at all? Like a resistor network that's missing? I wondered why I had one left, so yeah, it's over here somewhere. Yeah, I've got one extra. I thought it was a spare. No, it's not. There are precisely the number of resistor networks I need. So anyway, let's just use the braid. And it may move when I do this. Try and do this and do this at a distance. Oh yeah, I've moved it, look. Just get some solder on that one pin. This is the thing where just use magnification. Don't try and guess from a distance like I'm doing here. Yeah, I'm going to mess that up. I'll report back in a minute when I've used some magnification. So, there we go. Final component installed. Let's now clean it up again. Glad I didn't ultrasonic it, because obviously we've got all this flux around here that needs to be cleaned off. So I'll just inspect around that CPLD, because when you've reflowed like that, you do want to make sure you've not introduced a bridge. Here we go. Right, let's try it now. Push the front in first, then the back, and the front. There we go. So yeah, the power things like this is what you've got to be careful of. All you need is something short in there and you're going to have a very bad day. With strap on, I'm just going to touch here. Just make sure nothing's hot. Nope. Yeah, I don't think you saw that. It goes 480i, I think it's off. Tell you what, let's just boot it to the desktop. Maybe when it's in a different resolution we may see something. This might be my TV not liking the resolution actually. Hang on a minute. So just inspecting here. Something else. This here. I thought this were flyers, yeah, but you'd have a single strip for red, green, blue. They're actually jumpers, yeah. They actually break the traces going to the video connector here. How do I know that? If you look at the video connector here, the 15-pin ID connector, the traces go from these pads here, yeah. Now on the other side it's clearly marked RGBH VH. That's what it is, it's joining them over. So this is why I'm getting no blooming video. I'm amazed it even came up saying 480i, to be honest, because there's nothing even going across. So yeah, I need to put jumper. So that's a little bit crazy. Why would you want to disconnect them completely? I don't know. That's bizarre. So before I worked out those jumpers, this is where I was up to. I was tested with another monitor and there was nothing at all. It had the yellow standby. So now it is booting. Oh, hang on a minute, we've got a desktop. We have a desktop. You can't see it, it's so dim. Now that's the irony actually. Sparks UK was saying on his it's too bright. I can't see it, but that looks like that's worked, doesn't it? Let's cut over to the TV. Yeah, just moving the camera there so you can see it is actually working. Yeah, let's cut over to the main TV because hopefully it will be more visible. There's a funny coloured band at the top there. The VGA is now plugged in, so if we switch the TV over to the right channel, see what happens there. 576p. We've got the same thing, look. It's dark. How is it I've got a dark problem? Yeah. Those guys got a brightness problem. Let's just press these switches. Lost it. Down one. Doesn't do anything. The other switch, hang on. Yeah, that doesn't really do anything either, does it? So, why is it so dark? Yeah, it's working as you can see, but it's dark, and we've got this dark band right at the top. So, yeah, the video looks really crystal clear there, just dark. Right, it's all working. Let's just test this battery here. Actually, I just want to see how many volts this battery is measuring. There you go, 0.7 volt. That's why it's lost the date. So yeah, we'll take this battery out. You just pull the clip, and then it should just lift out. That's it. So we'll get a new one of those in. So what was the final piece of the puzzle? Well, I'll show you when I clean this in the ultrasonic in a minute, but one of the ferrite beads was not fitted there, and I'd got through all the components, didn't spot that was missing, just assumed it was a deliberate omission, and it isn't. Yeah, the dark thing, the dark display, I was looking at this LM385 here, and I tried a few things. I tried shorting a couple of the pins together. There's no connected pin and the ground, and I think Live 2 had suggested to Sparks you need to do that. That didn't make a difference. And then I was measuring voltages around here, and I saw 0.2 volts coming from the DAC here, the ADC device, and I thought that can't be right, because it's supposed to be regulating this to about 1.2 volts, this device, and you need more than 1.2 volts going into it in order to achieve that. So I was then looking at the schematics and I spotted the VCC pin on this ADC chip. It goes to that far right beat that was missing. So I was looking at the board layout in Eagle and zoomed in on it, and yeah, confirmed that that is where the VCC comes into that chip. And I thought, well, that must be the issue. I'm just going to go and ask about FB8. And as soon as I went back on Discord, Liv2 had posted, have you got FB8 fitted, by the way? Because, you know, you need that. I was like, there you go. I was just about to ask you that question. So, and I'll show you. I've taken a screenshot whilst I was in there, showing you the layout so you can see exactly where that far right bead sits. But that's what it was. This chip was not getting 5 volts, which meant his VREF pin was outputting 0.2 volt, which was going to the diode here, which should regulate to 1.2 volts. And actually that diode, I took that off, measured it in my component tester there, and it said it's got a forward switching voltage of 2.5 volts. And I think that makes sense. I think, but you need more than the 2.5 volts in order for it to switch. So yeah, that was the final piece of the puzzle. So as you'll see in a minute, it works perfectly. Anyway, let's just replace that. Right, I've got another battery here. This one was one that was already open, so I'm going to go with this, I think. Let's just measure it. 3.095, so let's get that in. And the OCD side of me is just going to polish the top of that, because I actually hate when I see a battery that's got a smeary fingerprint on it. There we go, looks nice and shiny. And obviously I need to set the time and date again. So that's booted up and it's RGB. The time and date is really wrong there, it says year 27. And if we go to VGA, 576p, there we go, give it a second, look at that, crystal clear. And it's Scandoubler, De-Interlaced. You can see that because as you move the cursor around, it looks a little bit artifacty. You see little lines, and that's just an artifact of De-Interlace, and I don't think you can avoid that really. But it's flicker free. The only flicker is the very top scan line or so there. Flickers a little bit, just when you move it. In fact, it flickers pretty consistently, that top scan line. So I don't know, that might be a firmware tweak that could fix that, I don't know. But anyway, the display in general is rock solid. Now one thing you may be able to see down there are some like little jail bars down the display. Now that's the cable. I talked about that in another video recently where I had a VGA thing connected up to the same cable on the TV here. So the impedance and stuff of the cable there and the shielding, you can get these little lines that come down the display there. I've seen that, I saw that back in the day actually. We were asked to purchase a cable of, I think it was something like 10 metres VGA cable to connect to a screen that was going on a wall somewhere, and this is exactly what we saw. So these lines, and we ended up having to change that cable for one that was a lot more expensive. I'm talking like £100 more expensive, that had sufficient shielding and had the right impedance there to avoid those lines on such a long distance. Yeah, it was an expensive cable, that. Yeah, so you can see those lines down the display there. As I said, that's the VGA cable. It's crystal clear though. It's, you know, it's there. It's on par, if not better, than the HDMI stuff actually. I'm really pleased though, because I can connect my A4000 up to a VGA display now. I actually prefer this as a solution rather than using RTG. But of course, I could just pair this up with an RTG card. I mean, I could use the GBA P2 Plus with this. I wonder if that's a resolution that it can't scan double. I don't know. Let's just try the switches on the back. It is. That's. Yeah, I'm not sure what that switch does. Let's try the other switch. I don't understand that. So we've got an issue there. When that switches up like that, you can see we get some sort of attempt to pass through the display. So a few things still outstanding. I need to ultrasonic this. I may do that in a minute. There's a key here, you know, one of these, you know, pin header thing. You should really fit for USB, yeah, and that's what this is for, so that you can, you know, USB thing in your system, you can plug that little extender on, plug it here, and you've got your ports on the back at the same time as this other stuff. But the other thing I'm going to do before I ultrasonic it is just file down here, because I'm having incredible problems getting this in and out of the 4000, but also I'm just about to test on the 2000 again. Couldn't get it working earlier in the 2000, and you'll see it's really, well, it was really tight going in there, so hopefully it'll be easier to get in and out after this. finally that little connector on the end. So this is the difference between the 2000 video slot and 4000. 4000's got this extra section at the end there. And Pillock pointed this out. I hadn't looked at the schematics, but I figured there must be some sort of compatibility between these two, so that you can fit one of the original De-Interlace cards into a 4000. And he was saying that it's the colour bits are shifted around, I think. So I would assume this probably carries the lower significant bits in colour, and the upper ones are probably somewhere up here. Which would mean that as long as you've used the lower colour depth resolutions, it should just work, I think, in a 2000. I think that's the idea. Yeah, there we go. I'm comfortable with that. So we'll just go try that ultrasonic it after that, because it's got still bits of flux, fingerprints, etc. So the fix to reduce the brightness there was to solder those two pins on that diode there, you know, the voltage reference, and that gives a normal level of brightness. It's this top end here, I think. Yeah, that top slot is still a bit tight. When I say slot, I mean the top connector. This connector seems alright. Right, let's give that a try. Now, Sparks UK and Live2, I think, tested this and they said it worked. But, as you'll see, if I go to the, look, hang on, 480p, yeah, and we get nothing coming out of it. Nothing at all. Now, I think this is, I think I've seen this before on another video, you'll see. I'm not going to spoil it, but I think I know what this is. I'm just going to try and change something that I think might have an effect here. I shouldn't do all this on, but... Right, so we've got RGB. Let's now go to that. Yeah, it's the same problem. It's the same problem. The interesting thing there, can you see, first time here we've got a bit of an artifact. We've got a little green thing and a red thing. So, yeah, that is interesting. You know, up here, I'm not sure you can see the odd pixel flicker in here. So, yeah, there's a subtle difference there. And it may relate to this specific revision board, but it could also be my board. Maybe there's an issue, because I tested another De-Interlace card on there and had a similar sort of thing. But then again, I was able to dial that in. This has got no manual adjustments on it, this one. You know, the clock PLL stuff is done internally in the CPLD there, I think. I think that's how it's working. But, yeah, we do have, I'll zoom you in. Yeah, zoomed you in a bit there. There's a green blip here and a red blip to the right that's barely visible. So, yeah, this text here is fairly stable, but I can see it looks a bit squished here just a tiny bit, and there's a tiny bit of shimmering. Like, you might not see it on the capture here. Yeah, again, it may get lost in compression, but yeah, there's just like a little bit of flicker. If you watch these, the yellow and orange bit here, there's like a little bit of flickering going on. Just a little bit. I can see the odd pixel flickering there. Anyway, the main thing is it is working on the 2000, but it didn't do at the start with just a black screen. And how I got it working then was I disabled the IDE first of all, just removed the card, and then I powered it on and I changed this jumper over. Yeah, this one back here is for the CIA tick, I think. Instead of taking it from the power supply, if you've got genuine 2000, the Amiga 2000 will be passing a 50 or 60 hertz tick from the mains, you know, like a reference, you know, clock thing, tick. You know, it's based on the frequency of your AC mains. So in the US, you can have 60 hertz PSU, yeah? And that 60 hertz tick comes down here to one of these pins somewhere near the end here, and it gets picked up in the rest of the system and used for, you know, counting frames and timers and all that. I think it may be used for part of the VBlank timing stuff. I honestly don't know what's going on. I need to have a look at that now. I think I need to go and look at where the tick signal comes in. I need to look at where what that jumper does and see if I can understand what the difference might be. But if I switch this off and on now, yeah, I suspect in this position it's just going to boot loop. So it takes a while for it to give up looking for the IDE. But you see, if that jumper's in the wrong position, it will just it'll boot loop, it'll reset. Yeah, look, it's resetting. So I need to change that jumper back again. I'm doing it while it's on, shouldn't do that, but I've got a wrist strap on. So now it's in the right position. It'll probably give us a guru, maybe. No, it's boot loops again. Let's just see what happens this time. This time I suspect it will boot though. Yeah, there we go, there's the guru, and that's because I changed that jumper in real time. Then it should come up with a kickstart screen there. or stick your workbench disc in. So that's that. But if we now switch, and this is the key, here's what I'm trying to show you. If I switch to VGA, here we go, it'll say 480p, and we just get a black screen. This is the thing, this is my first experience of trying it with the 2000 here. So I'm like, why doesn't it work in the 2000? And then I remembered what you'll see in the De-Interlace card video, another one, not this one, another one, fixing one for Tom Meads. And if I change that jumper over, watch, the screen will change, probably. There we go. And in that position it works. Now if I switch it back over, maybe it'll still continue to work. No, it won't. This is exactly what I saw on the De-Interlace card. It's got to be in the other position, the position where when you try and boot it, it will fail to boot. So in that position, it works. So I don't know, I'm going to go hit the schematics. I'll talk to the guys in Discord a little bit about this, see if anybody's got any clues. But it does work on the 2000, but I would suggest the way things are at this point in the video, you need an official power supply that's providing that tick signal. Hey, I fixed it. It's a Stephen Leary thing, this. Not directly, he hasn't contacted me, but I remembered. I've learnt from the Master Jedi. I used a Schmidt trigger on that jumper. That's what I'll show you in a minute. It's crazy. I've just soldered it across a couple of the rails on the top side, got a couple of clips there, precariously balanced, made sure you're not got any shorts, and it just works. Yeah. The idea being, I don't really think it needs to be a Schmidt. I think that signal just needs buffering. I think that's perhaps what the issue is. There might be even some reflection or something going on when it's, I don't know. You'd think if there was reflection on the VSYNC line, it would affect the video quality in general, but nevertheless, by putting a Schmidt trigger on there, it just works. And I'm guessing this will work with the other De-Interlace cards, so this will be an update to that video as well, the one you haven't seen yet. So yeah, we still got that green dot there, the red dot. I'm not really too concerned about that. That looks pretty darned good, actually. And you can see my little bodge there. It's soldered onto the two power rails here with the pins bent up. It's a tiny little, I don't know, SOT23 thing. It's tiny. But what I can do now, you see, is take that off, solder it on the underside, add a couple of pieces of Kynar just under the jumper here, so that, thinking about this, yeah, what I might need to do is cut the trace on the right hand side here from where that comes in and pass it through the Schmidt trigger to the jumper. So the jumper will still work as normal, but it will be buffered. The VSYNC will be buffered by the Schmidt trigger when it's in that position there, and that just works. So I'm very, very pleased because, yeah, well, that's a mod that's never been done before as far as I know. I searched online high and low, and the best I could find is people complaining, saying, well, some of these cards, a lot of them, don't work unless you've got the tick signal. There's something to do with the loading of that line. And that was the thing, if I'm honest, gave me the clue, thinking, maybe I should just buffer it. Let's see what happens if we buffer it. And I considered just using 7.4 series, but then you've got propagation times and things. I thought with the Schmidt, it's going to be pretty down quick, and it's going to be right on the edge, isn't it? This is the thing. So, and that works. So I'm very pleased. Let's just power this off now, just make sure it wasn't a fluke, and we'll get the compact flash card back into here. And of course we may see evidence of that if we scope that signal. I don't know. So there's our little mod. Now I tested this with the other De-Interlace card, and initially it didn't work. I think what I need to do on that one though is tweak the PLL stuff. It's got like a little variable cap on there. I think some adjustment is needed. But we may need to revert this, I don't know, but for the moment I have just modded this. So I cut the trace there that goes up to the right hand pin, yeah, of that J300. And obviously I've got two things joined on here. The Schmidt trigger has got VSYNC ground on the rails here. It's like right in between them, dead easy to solder on. And I bent the two pins up to be able to solder on, so the pin on the right of that Schmidt trigger there is going to the centre pin, so that's the out, and the input comes from the side that was cut off down here. So this is where the VSYNC comes out, goes to the jumper normally. So it's really easy to revert. You just remove all that stuff and then just put a little bridge wire across there, or from there to there. So it's not a huge awkward, messy mod or whatever. I just need to make sure you've not got any shorts there now, because the last thing you want is to short your VSYNC to 5 volts or ground. And I need to clean up on this side, because this is where I had it originally. I bodged it between these two rails here, like the outer, the one nearest us here is 5 volts, that one's ground. So I had the 5 volts and ground soldered on, and then you saw the clips there you used to clip the input and the output to the respective pins there. So here we are almost 5 months later on the new bench, actually, in the new workshop, I guess you could call it. And yeah, when I did that little mod there, I tested it and it worked, and then I tested it, I don't know, a day later, it wasn't working. Now, one thought did just cross my mind. I'm wondering if that Schmidt trigger is a 3.3 volt part, so this may work for a short period and then it may die. I'm retesting it here. I've got it on a little SOT23 adapter. I'll show you that in a minute, and I've put a couple of jumper wires on it and I've connected them to the pin headers, and it seems to be working. And you can see that there, I've got a VGA monitor connected as well as the CRT, and it just works. It works from power on without an issue. So the next thing I need to do is just scope the VSYNC signal that's going to the CIA. Now, I did this previously, and I can show you that by just reinstalling the jumper and removing this little mod. It's dead easy to do because it's detachable at the moment. It's just using DuPont cables. But I couldn't quite see what was wrong with it when I was scoping it. What I did work out is the VSYNC signal, whilst that seems to be the issue here in terms of does it come from the tick from the power supply. Is that frozen? Not sure if the floppy drive's having problems reading there, or yeah, the floppy drive had an issue there. Just lifted it up. The motor was being restricted on the underneath. That's what it was. But anyway, sorry. Yeah, well, let's just switch it off again. Switch it on. That music is really annoying. The VSYNC goes to the CIA. Either comes from the tick, which comes from the power supply, or it comes from the VSYNC signal, which comes out of Agnes, I think. Now, the interesting thing, and I noticed this on another one of these cards as well, a similar one. It's not the same card as shown in this video, different one I'm looking at for Tom Meads. The problem was the same there in that if you removed the jumper completely and put it to the left side so that the CIA gets its tick from the power supply, which I'm not providing, then the video would kick into action. Yeah. Now, that made me think, okay, is the CIA affecting the VSYNC in some way that then goes to the card? And when it's switched in the other position, it seems happier. So I traced to the card. The VSYNC doesn't actually go to the card. It goes to the slot, but it doesn't go to this graphics card. VSYNC is not used. It must be used in the C-Sync. So then I was like, well, how on earth is the VSYNC interfering? The only thing I could find with the VSYNC signal, it doesn't hold a steady 50 Hertz. It's on the scope, it shows like 50, and then suddenly it goes 25, 50, 25, 50, as if occasionally there's some glitching occurring there. Now, I tried terminating that signal with a resistor. It didn't seem to make any difference, so I thought, well, let's go back to doing what we did previously, which I thought had worked, but stopped working for some reason, and it seems to be working again. So yeah, I'm going to go look at the datasheet in a minute just to make sure that part is a 5 volt tolerant part, and if it is, then I'll permanently mount it on here and just do some more extended testing. But right now it seems like I've found a solution to this problem that's plagued these cards for a number of years. Now, there are fixes. You can just get a 50 Hertz generator. It's a little, use a 555 timer or something like that and generate your own 50 Hertz signal. But this is, I guess, easy to fit and just seems to solve the problem, and it's pretty cheap. A Schmidt trigger, what's about 50p or a pound or something. And you can see at the moment I've just got this little board floating here with the Schmidt trigger on it. It's a Schmidt buffer, and we've got input and output, and they're just going to the jumper. I'll show you in a sec. The jumper positions down here. In fact, if I move the drive, you can see it. Yeah, you've got your 3-pin jumper. The middle pin is the input. The inputs to the board. The outputs is the green. So it's going, it's going out of Agnes effectively into the Schmidt, and then back into where it would go to the CIA. And that seems to work. And with the probe just precariously wedged into the point on the side there, looking at the scope, I don't really see much of a difference. The Vmax is maybe slightly higher here. The frequency is almost the same, 49.921 generally, 922. And it still bobs around here just like it did, 50, 25, 50. This is to do with the sample window. If you're only capturing showing a small amount like this here, then obviously it's going to have a lesser accurate representation. And obviously you can see that the update is really slow there, and then it shows this completely wrong down here and up here as well, because the scope just can't handle it. Now maybe it's a mode thing. Someone can let me know what mode I should be in here or something, I don't know, to get a more accurate display when I'm scoping a frequency like that. Because it's not very fast, is it? It's only 50 Hz. It's not like I'm trying to scope a 25 megahertz signal or something. So it's interesting the update rate is so slow there. Yeah, so in general, what I'm trying to get at here is I don't really see anything different there, but it just works. You know, this is the thing. So I don't know. Was it a reflection issue? I read a number of comments saying it's something to do with how the VSync gets loaded down when it's connected to the CIA. So I mean, this would stop that because it's now buffered. The CIA is getting its signal from the Schmitt, which means the VSync has got no loading on it from the CIA pin perspective. But what else uses that VSync? Because I thought this was all about C-Sync, because the graphics card does not use the VSync. So I guess what I really should do is I'll look back at the schematics, follow back the VSync, and see how. I don't understand how that could affect the C-Sync. I don't know. Maybe. I don't know. It's a mystery to me at this stage. Right, there's our bodger board trademark. Yeah, I'll put the pin out for this so you can work it out yourself. But it's just soldered onto that little adapter there. It's held down with a sponge pad. Ignore this here. Someone previously melted that when they worked on this board with hot air. It's just something I never showed in the original repair. It's just a bit heated around here. You know, it's been heated. It doesn't clean up anyway. Anyway, the VSync comes up here to the right hand pin and it's cut. I cut that a while back. So yeah, the VSync comes in to my adapter here, into the input of the Schmitt. Yeah, the ground comes down here to this point. This is a ground rail here. VCC comes across here down to this rail here. Yeah, and then the output from this Schmitt buffer here goes to the center pin. So I can still switch between, you know, the power supply, tick signal, and VSync. But VSync now is buffered by this Schmitt. So there we are, all modded. Now there was a mistake, I don't know if you spotted it. This jump here, the pin to the right, yeah, the VSync comes from the Agnes direct to that pin on the top side of the board via here. So I had to cut the trace on the underside, I'll show you that in a minute, and then join a wire from the VSync connection here all the way back to where the little bodge underneath is picking up the signal. You know, it gets merged with the trace that I cut under there. So yeah, learn from my mistakes. You could do this a little bit easier perhaps by maybe cutting a trace on the top side here, or just do what I did when I tested this a minute ago and have your little mod on the top here, have some jumpers and have it, you know, take the input into the chip and then the output to the center pin. That's perhaps a better way of doing it, a non-intrusive way rather than cutting traces. But I've got this working, I haven't cut the traces. But obviously you'd have to fix those traces if you want to remove that little bodge. Now, thinking about this, I was trying to work out how is this working, and I actually think that perhaps all that's going on here is a delay, because I'll show you the schematics in a minute. The VSync and C-Sync come out of Agnes, yeah? The only difference between the two is the C-Sync on the 2000 gets buffered. So that might be the issue, because of the propagation delays. It comes out of this pin here effectively into our bodge board and then into the sensor pin. You know, that's the equivalent of what we're doing here. That slight delay through the Schmitt, maybe that's the answer. I don't think it's just about it cleaning the edge of the signal up there. I think maybe it's a tiny propagation delay that means it just works. But the good news is I don't need to do anything with the 50 Hz tick mod, you know, get a little 555 time or anything like that. And it's revertible, you know, in the sense that if I just switch this jumper over, it'll work with the power supply as normal. And no issues so far from all the testing I've done. But I'll connect an IDE interface up now and I don't know, a CPU accelerated card, test a load of games out, just make sure that everything seems to behave normally. I'll also need to check the CIA timings and stuff, just to make sure there's no timing issues introduced by doing this. And you can see tested on the VGA screen there, timers all okay, all tests passed. V-blank frequency 49.92, that's what we've seen on the scope, so that all seems correct. So at the point where I said it stopped working, there's a reason. Because I migrated the mod from the top side when I first tested on the 2000 to the bottom side of the board. And what I didn't realise is there's a technical difference. When you cut the trace here and mount this as I did, as I showed you a minute or two back, what I didn't realise is the jumper that's cut off there also connects up all the way over here, or via a via and then a trace on this side, I think, to the Agnes. The VSync comes out here, yeah, and because I've only cut the trace on one side, it wasn't working. Yeah, it wasn't working. So what I had to do is find the follow this trace here, goes through a via or something, comes up somewhere else, cut a trace around here somewhere. I'll show you where that is in a sec, and then join a wire straight from VSync over here to the same point we've tapped off the point where it was cut off here, if that makes sense. So yeah, it's a bit of a bodge really, but it does work perfectly, and you could revert it by just removing this stuff and just fixing the two traces. But if you were to remove the jumper, you may be able to see the issue, because on the top side here, that's the pin that we cut off also, like I say, goes over here. So I'm not really sure how best to do that other than cutting the two traces. But yeah, so on this Rev 6 2000, the trace head cut was here. It comes out of a via here, I think, and then goes all the way over to the pin on the Agnes there. So yeah, I had to cut that. So just so it's crystal clear, and you could do this mod obviously on a Rev 4 2000, it might be slightly, well, it's going to be slightly different in terms of the trace layout probably. But on this connector here, to the right hand side, the right hand pin, that's where VSync comes from the Agnes, but it goes to two traces. That's why I had to cut two traces, yeah, to remove it from that pin. And then the way this is working, if I remove this jumper, the little buffer board is taking those two signals that come ultimately from the Agnes and somewhere else, yeah, the cut off from the left pin to go into the input on the Schmidt. The output of the Schmidt goes to here. So if this right hand pin is still VSync as it always was, but it's now buffered. Yeah, so then you've still got this ability to use the power supply tick to the left, so that would come from the power supply, or the buffered VSync to the right. Bear in mind you've got approximately 5 nanoseconds propagation delay on that. So, and what that means is, as it goes high and low, yeah, normally, because of that buffer, we've added in a small 5 nanoseconds delay. Yeah, so that could affect things, but all the testing I've done has shown that it makes no difference whatsoever. It has no effect on some of the issues you'll see in the rest of this video and in the next part. And it just works perfectly. So yeah, that's a nice easy mod you can do. Over the years, people have developed other solutions like adding a 555 timer and feeding that into the center pin here. You could do that. And similar things, you could use an Arduino or something to divide the main clock down to get 50 Hertz or 60 Hertz and feed that in there. But why do that when you can just literally buffer it? And thinking about things out loud here, why was this causing it to not work until I buffered that signal? And I'm wondering actually if the VSync comes out of here, yeah, and even though it's coming out VSync, you've got C-Sync coming out of here. What is C-Sync? It's combined VSync and H-Sync. And if it's not buffered on its VSync output here, and that VSync as well as coming out goes into the internal buffering for the C-Sync, as a result of any noise, caused by loading or reflection or something on the VSync line, i.e. by feeding it to the CIA on its long, crazy routed, connection from here to here, in theory, when it goes into the buffering for the C-Sync to get merged with H-Sync, that glitch would translate as well. So I'm wondering if that's what that is. I'm wondering but what I don't understand is why it only becomes a problem with an RTG, a graphics card, not an RTG card, a graphics card there that's using what I presume is using that C-Sync, because I did measure connectivity up here. It doesn't seem to be using VSync. And this is the thing, I was trying to understand the relationship between this jumper, VSync feeding in here versus the power supply tick, and this card not doing anything. It didn't seem to make sense to me. Once this VSync is buffered, the card then works, it isn't using VSync. Therefore, what else uses VSync? Well, I looked at the schematics and there's literally nothing else on here that takes that signal. So it has to be noise on the VSync, yeah, or reflection when you feed the VSync through to the tick on here, which means that back feeds into where it produces the C-Sync. Post your comments and theories and things down below. It's got to be that. I can't think what else it could be. Because the other theory I had, you know, is thinking about the propagation. Is it the delay? Is adding a 5 nanoseconds delay on here the issue? Well, nothing else picks this up apart from the CIA here. So then you're like, well, is it the time of the CIA? Well, the time is identical now. It's not any different. And furthermore, if you then consider the other, you know, third-party fixes for this over the years, i.e. a 555 timer, it's not PLL synchronized to anything, yeah? Generally, the fix for that is they just create a 555 timer that outputs 50 or 60 hertz and feed it into the center pin, yeah? There's no, you know, locking of the frequency in relation to any other frequency on here in that scenario. So, you know, when you power it on, based on how that 555 timer board has been set up and the components and things on it, the pulses can be anywhere in terms of the synchronization. Obviously, you're going to have your regular 50 or 60 hertz, but the whole point is the alignment of them is going to be way more than the 5 nanoseconds difference here, yeah, from my buffer. So, even that theory kind of has no merit. It isn't about the fact that we've got some propagation on the VSYNC that makes this work. It is literally because the VSYNC is buffered. This can't basically annoy the C-Sync here, I think. I think that's what's going on. So testing with a TF536 here, nice way to add RAM, IDE, and a fast CPU. And obviously, this is the inspiration of this fix here, actually, the Schmidt on this. So let's just see if this boots. I saw the coloured bands there. I'm not sure if the LEDs are going to... Oh, there we go. Yeah, flash on here. Yeah, I'm not sure if you saw that. It's just off camera. Yeah, so we missed the bands, but I saw those on the CRT. So, let's say CRT, the LCD TV on the wall. Because, obviously, it takes time for it to start to, you know, do the De-Interlace stuff there. But we got our desktop up. Look, hey, it's fantastic. Now, if it's not lost in compression, you may see lines coming down the screen there. Those striations, that's the sort of terminology used to describe those. Well, it's from my experience from when I was in the trade. I've got first-hand experience of seeing those on VGA. I know exactly what causes them. It's the cable. Not sure if PIDI is AGA only. I don't think it is. It seems to be working. I don't know what made me think it was an AGA game. Yeah, sound's coming from the left here, by the way, because it's the TV on the wall where the sound's coming out of. But that's fantastic. And you can see it's working fine on the normal TV here, using the analog output from the back. And it's fine on the LCD monitor down here, the VGA output. So an interesting problem here, agony. Now, this is in 60Hz mode at the moment. I booted the Amiga in 60Hz. Now, the edges on the text are fine here, and that fixed that. But can you see all these flickering pixels here? I'm not sure if this is a consequence of the RAM that's on this card at the moment, whether it's a bug with the card, because it's obviously, you know, it's not 100% bug-free. Maybe it doesn't work very well with interlace modes, but I mean, it's a De-Interlace card, isn't it, effectively? No, well, a Scandoubler, primarily. So yeah, that's strange, isn't it? And if I, like I say, if I load this, I'll do it again. I'll load it in PAL this time. You'll see it's far worse. And the way you do that is you hold both mouse buttons down. And I'm not even sure you get a true 60Hz when you do this, actually, but you've got display options. You can choose PAL or NTSC, so we'll just go with PAL. But that's how I put it in NTSC a minute ago. Yeah, so my guess is it's perhaps about the speed of the RAM. Now, it fits the screen better here in PAL. Everything here looks perfect, crystal clear. There's perhaps the odd shimmering if you look, but yeah, that's pretty stable. And that's obviously in the interlace mode there. That looks fine. That looks fine. There's a wee bit of shimmering here going on. Now, some of the De-Interlace cards out there, or Scandoublers and stuff, have an adjustment where you can adjust the, you know, the pixel edge there just slightly to solve that. Now, you might be able to see, yeah, you can see straight away, you can see this is blurry now. It's like every other line, the alignment's off. And there's a lot more stuff going on up there. I'm going to zoom you in a bit there so you can see what I'm talking about here. See this? And can you see the edges of the white text? It's like jittering and all over the place. It's like every other scan line is, the timing's off. So yeah, I'm thinking the RAM speed could be the thing. But it could also just be, you know, it needs a firmware tweak or something like that. There are some switches on the back. Let's just try and switch those. See if that makes any difference. So that's the first one. Just lose the video completely and switch it back. And then the hang on. Yeah, the bottom one. Again, I just lose the video completely, so that hasn't fixed it. So yeah, I'm not really sure. I mean, there's probably a few games that use that mode there where you get interlacing going on. So trying a different firmware here. This is the one that ends in -0. There's only 2 there available, I think, at the moment. And one of the switches now works. Can you see that? We get like a brighter black or a darker black. So I quite like that actually. But obviously the interlace stuff's absolutely nuts now. So yeah, neither of these firmwares are 100% right, without a doubt. Unless it's the tolerance or something on one of the components on this card that's affecting, you know, the interlace mode. Because what it is, I think, like the first set of scan lines are probably aligned correctly, and then the second ones are off by pixel. I mean, not here. This is well out. This is like, I don't know, half a scan line out or something. It's really wrong, isn't it? So I do need to revert it to the other firmware. But it's interesting now that, hang on, where's it gone now? That switch to go dark black like that actually works. But it doesn't work with the other firmware, so yeah, I think I'll switch back to the other firmware and just put up with a slight jaggedness on interlaced stuff. So back with the other firmware, it's working again. So I'm just going to have to just live with the jaggedness there. That's quite annoying, but I mean, the other thought I did have is I could have a look at the VHDL for this, because it is open source. What's happening here, I think, is it does the capture of the first frame, yeah, and then we've got 1 pixel time difference somewhere where it starts to either capture the next frame or output the next frame, one of the two there. So it's like we need a pixel delay, or maybe not, we need to remove a 1 pixel delay somewhere. That's what the issue actually is. I don't know whether it's technically possible. It could be one of these limitations where, well, I don't know. It could be a limitation. The other thing, obviously, you know, I spent a lot of time thinking about the implications of my mod here, because this is back to the modded R6. Could modding the V-blank signal, you know, the VSYNC signal, cause this or affect this? And we've proven no, because I reverted to the Rev 4 and it does exactly the same without a mod on there. Exactly the same behaviour of the, you know, the jaggedness. So, and only in interlace stuff, incidentally. So yeah, it's got nothing to do with the mod. Wouldn't matter whether you've got an actual power supply that's providing 50Hz tick, or whether you've got a 555 timer providing that tick signal, or whether you've done the mod that I've shown in this video. So just a bit of final testing in this video. So the picture is still not perfect, and even though this looks perfect here, I've done some stuff that you'll see in part 2 to get this working. So yeah, it looks really good, doesn't it? Really pleased with this, it's fantastic. Looking crystal clear. Yeah, so you can see the lines that I talked about earlier down the display here. You might get a bit lost in translation, but your compression. But yeah, they're down the screen, but yeah, more about that in part 2, hopefully. Oh, look at that, that looks amazing. So I had to bring this video to a close. It's getting quite long, and there's quite a lot more in part 2. And some interesting stuff again. I know the build was a little bit long-winded here. It did take quite a while, and there were a few mistakes as I tested this, but we've got there in the end. There are obviously still these outstanding issues I'll talk about in a minute. A huge thanks to all the people that contribute towards this as a birthday present. It absolutely made my birthday really special this year. I've really enjoyed working on this, and yes, there has been a gap of a few months while I moved into this new environment and stuff here, onto the benches and things, but yeah, as you'll see in part 2, we pushed through these issues here, and it's a really nice card. So here's that pixel alignment issue. I'm not sure you can see that. It's like every other scan line is misaligned on certain interlace modes. It kind of gives it a blurry look actually from a distance here, but zooming in I can see that it's like every other scan line is 1 pixel out. So it's like if you started on the even scan lines, like 0 and 2, 4, etc. Those are correctly aligned, and then the interlaced frame, like lines 1, whatever, below onwards, they're off by a pixel. So anyway, we'll have a look at that in part 2. But there's also that flickering pixel issue, and obviously the switches on the back, I still haven't got it working where the black level goes blacker. A special thanks to Sparks UK for coordinating this and getting all the parts together, the PCB, etc. And some help, on these jumpers. He was the one that mentioned the jumpers and things here, and I think Liv2 did as well. And the diode, that was helpful information in terms of the brightness level mod there from Liv2. So I do hope you found the video interesting. Please like, share, subscribe. If you'd like to support the channel, please see Ko-fi and Patreon links. You can join as a YouTube member, and we've got some merchandise as well. All those things just help the channel keep growing and going. I'll catch you in the next video.